Okay, does everybody have the PowerPoint up on the screen?
Yes, sir.
Oh, good.
Yes.
Good. Okay. So when we see it in the movies and people talk about it, this is kind of the scene that we think of. Forcible entry, a firefighter with an axe in one hand and a Halligan in the other, all packed up, flames in the direction that he's headed. Although using a Halligan, he might not be using a pick-headed axe. But more so in reality, this is kind of the thing that we're doing. If we're just doing things quick and doing things fast and not really thinking through it, we may not be pushing toward incident command's goals if we just start swinging and breaking stuff. And we'll learn as we go through this that forcible entry is something that is not done randomly. It's not done without being ordered by incident command, and it's not done without having good strategic and tactical goals behind it. So learning objective 1 is the basic principles of forcible entry. As I mentioned, we want to try and cause minimal damage while we're providing access to an emergency. And Capper Chief, I have a go-to meeting that's partially over my screen. Is there a way to keep that from happening?
As far as, yeah, I think you can move that. I think it's a separate pop-up box that you can move. We should be able to see your slides clearly, but does that help?
Yeah, I'll manage.
Minimize that go-to meeting control panel. Just minimize it. One of the minus signs up top.
There could be, LT, if you're on the web browser version, there's a little arrow up in the top left corner, I believe, that'll shrink that box down.
Ah, thank you, Cap, or Chief. Perfect. Cool. Okay, so we're trying to cause minimal structural damage in order to accomplish the goal or the order, while providing as quick as an access as possible to whatever the particular emergency is. Buildings aren't the only thing that we try and make forcible entry into. Obviously, vehicles, and that's a whole nother science, essentially, is extrication, as well as railway passenger cars. We've actually had to take people off a railway train a couple of times here in Gilpin County. Didn't need to break into the car, but there could be a time when that could happen. There have been aircraft crashes, and shipboard things are pretty minimal up here. So as a situation occurs and forcible entry becomes part of the potential strategy and tactics, the incident commander, who is typically going to be the first Timberline member on scene, will have to start putting a plan together, determining what is the issue, what tactics can be used to mitigate whatever the issue is in the event of a fire or some other kind of hazard. Where is it exactly? Where in the building? Is there a part of a vehicle that's on fire? If there is a fire, what stage is the fire? Is it incipient at the very beginning? Is it in the growth stage where it's growing? It might be growing quickly, or it might be just smoldering around. It could be in the fully developed stage, or it might be in the decay stage. So depending on the stage of fire behavior, we may have different tactics and strategies that we utilize. Ventilation is what happens when you complete some fashion of forcible entry. So ventilation has very significant effects on most fire situations. So we'll be talking a lot about that today. And then what's the effort required to force the entry? Is it something that's easy and quick, or is it something that's going to take some time? Obviously, taking time is most times detrimental because fire is growing, people aren't able to breathe because of smoke. If we're trying to make entry because of a medical situation, somebody could be having significant medical issues where every minute counts. So we need to understand what is going to be the quickest, least destructive, most effective method to get into whatever we're trying to get into. Do we have the tools? Do we know how to use them? And then can we use them effectively as a crew to accomplish whatever the goal is? So as I mentioned, and we'll mention this a bunch of times, we never force entry without an order to do so. So the phrase there, try before you pry. Can anybody tell me what that might mean?
Try to open the door before you bust it open.
Yep, that's exactly it. A lot of times people will be working on a door for a few minutes when an officer or somebody with a little more experience will come up behind them, tell them, hey, stop for a second, reach over, turn the doorknob or turn the latch, and the door opens. So the time's been wasted and damage has been done that was unnecessary in order to accomplish the goal of getting inside. So always try before you pry, not only on doors, but on windows, sliding glass doors, vehicle doors. Anytime we have a potential forcible entry incident, we want to make sure to try first. After trying the normal entry, some buildings have a lock box. Sometimes it's called a Knox box, K-N-O-X, like Fort Knox. What these are boxes that we have a special key to on many of our apparatus. And that apparatus key will open all these lock boxes in the county. And inside that lock box is a key for that particular building or doorway. So as you guys start coming up and doing shifts and spending time driving around, whoever you're working with, ask them about knock boxes if they don't bring it up themselves. The court building, the rec center, Ameristar warehouse, one or two residences, larger residences, some residential gates might have a Knox box. It obviously, like it says there, avoids unnecessary damage, and if the Knox box is able to be opened easily enough, if it's been maintained, it could be quicker than forcing a door or window. So we have three areas. We have doors and locks, security barriers, which could be gates, security doors, both rigid doors and telescoping type doors, and then what are the tools that we have to defeat all of these types of barriers. You can see here, these guys are up on an aerial and there's some security bars across this particular window. He's up there with a circular, a rotary saw, reaching over to cut these things. Understanding what types of security barriers are in the district, in your first due area at the very least, but more ideally across the whole district is really important. Because if we get a call to one of these buildings, we have to know what we're going to be up against without having to spend a lot of time thinking. We can get off the truck with the correct tools, go to where we need to work, and get going without having to go back and truck, which will sometimes cause a lot of time. Also, we need to understand what knowledge is necessary for defeating these barriers, what tools beyond our normal forcible entry tools, and then how are we going to be approaching these to defeat them. So the first set of construction details that we'll be talking about are the typical lock sets. So obviously A lock set describes all types of door latches, locks, and locking devices. Apparatus, set the air brake, chock it, and through this whole thing, all of us should be sizing up what we're seeing. How difficult is it to get to the building? If we know we're going to be making some type of forcible entry, what side of the building are we going to be wanting to do that on? What types of doors or locks might there be? And understanding that will help us go a long way towards saving time. So door locks and latches on all exterior and many interior doors. We have latches. We have a number of different kinds of locks, which are typical or traditional, and then we have non-traditional locks. So one of the first ones here is a mortise lock. It's mounted into a mortise, which is basically a routed out groove in the side of a door. Rectangular in shape. It has a lock bolt and a latch bolt, and then some type of handle or knob. Cylindrical locks are the most common. They have two holes. One is bored through the door, and then one is bored into the edge of the door where the latch assembly is slid into the door itself. And then the strike plate is on the door jamb. That's what the latch assembly clicks into and holds the door closed. A lot of times it'll be a keyway on one side on the exterior knob, which has a key opening. On the inside, there may be no lock. There may be a push button knob for locking. There may be a thumb lock. And sometimes the inside actually will have a keyway as well. But as you get through and you're reading the Essentials book, make sure to go through this because sometimes there's questions on both the Timberline test and the state test about parts of locks. The left-hand side photos there that has the key and knob. You have a knob, the interior knob is the inside knob. It has a push button or a turn button for locking. And here you can see the outside key way where it's used to lock and unlock. Tubular deadbolt will have a thumb latch on one side, and there may be nothing on the other side, or could be a keyway on the other side of that deadbolt. If any of these locking mechanisms are in a wood door, sometimes the easiest way is just to breach the door itself, force the door. And we'll get talking about details of forcing in a moment. Here you can see there's 3 locking mechanisms on this particular door. The latch, the handle down here probably has some type of push button lock. So that latch will be locked. There's a deadbolt that has an exterior keyway, probably has the thumb latch on the inside, and then there's another deadbolt up here. So if you try and approach defeating these latches, you're obviously having to defeat 3 separate things where you might go after the door itself. Most of the time, some of these will all happen at the same time as you start to work on the door itself. All 3 of these latches being fairly centralized will fail in one way or another fairly readily. Rim locks are mounted on the interior of the door surface. We don't see a lot of these in current new construction, but a lot of older buildings will have these. A night latch on the left-hand side there, it can be latched open by retracting the latch and then pushing this button up or down. What that'll do is it'll keep the latch retract, and then the door just opens with the knob. As a night latch, it is automatically locked as the door is closed if this is in the freed position. Deadbolts, of course, have a locking mechanism on the inside. And then a vertical deadbolt, it has a locking mechanism that goes vertically through the latch plate that's attached to the door jamb and the lock housing itself. Now, these types of locks are sometimes surprising because many times the hardware can't be seen from the outside. So from the direction we're looking, we may not know these are there. So we have some tactics that we can use to understand how the door may be protected, and then that gives us an idea of what we're going to have to do to defeat it. High security locks, multiple bolts as shown there on the left-hand side. There may be one latch or a number of latches that push all four of these locking mechanisms into the door frame. Obviously, that creates a fairly robust forcible entry challenge. Then we have the electronic or digital locks shown in the center there. These are similar to the latches and locks that we have on the stations. Sometimes they're difficult to defeat, sometimes they're not so difficult to defeat. It depends on how that latch plate in the door jamb is protected. And then electromagnetic locks used in many commercial applications. Electromagnetic lock is basically just a kick-ass magnet. And when the door is latched and the mechanism is turned on, the magnetic force holds these blocks against the locking mechanism on the door frame itself, and they're virtually impossible to pull apart. When the electricity is shut off, these are typically programmed so that any electromagnetic lock will open. So it's a fail-safe open. But if we have to defeat these without the power being turned off, we'll have to take some additional measures, and probably won't mean actually getting through that electromagnetic feature. We'll end up having to do something else. Other locking devices, padlocks. These are pretty obvious. They have a hasp and then a lock that goes through the hasp itself. Some padlocks are pretty easy to defeat. Some are case hardened and pretty significant. And then as seen on the right-hand side there, drop bars, there may be chains. Sometimes we'll see chains on the panic hardware. Those bars down here are called panic bars. They're required, some type of this is required in any commercial occupancy, which will allow interior occupants to vacate the building easily. A lot of times we'll see drop bars in commercial buildings on back or side doors where there's not a lot of visibility, and the building owners or lessees will obviously want to harden their building to a point where it makes it extremely difficult for us to enter if we need to get inside. Padlocks, portable or detachable locking device, divided into two types, standard and heavy duty. So you can see the parts of a padlock here. There's a shackle. The tumbler inside is where the key goes into and the pins are located. The case or the body itself, sometimes a drain hole, depending on what the type of lock it is, if it's used for use outside or not. The key itself, shackle heel and shackle toe. This is important, especially on heavy duty locks. So when we decide what side of the shackle we need to cut, we need to understand, do we need to cut both the toe side and the heel side, or is just one necessary to cut? Sometimes in the heavier duty locks, the shackle will not rotate unless the shackle is opened. In lower quality and less expensive locks, if we cut the section here on the toe side, the shackle may allow us to rotate that relative to the case body. In heavier duty or more high security padlocks, there is the way the case body and the shackle is put together, the shackle is not able to be turned unless this is lifted up. So you can think of the shackle heel and toe just like your foot. If you're standing on your foot, you can move your toes back and forth and rotate them, unless you stand on your toe, but that's one way of remembering it. Other locking devices, we talked about drop bars already, door chains and door limiters. These are similar to what we see in most hotels. Surface bolts. These are surface bolts or slide bolts. They're usually screwed on to the inside of the door and then has a component that gets screwed into the door frame itself, or there might be a recess in the door frame that the surface bolt will slide into. And then there's an internal mounted bolt. You see these on double doors. A lot of residential double doors will have an internal mounted bolt. It's on the edge of the door, and the ones on top press up, the ones on the bottom press down. It allows you to lock that non-functioning side of the door, or when you release the internal mounted bolts, you can then open the door and have a double width door. So what do we need to consider when we're using forcible entry tools? PPE obviously is of extreme importance. Anybody tell me what type of PPE we might be looking at donning when we get ordered to perform a forcible entry?
Helmet,
Good.
gloves.
Glasses.
Yep. Bunker gear. Sometimes ear protection. Ear protection is something that we don't normally think about when we're on an incident.
Conference will now be recorded.
The internet over at Station 8 is a relay off of firefighter Jovich's house, and the router at his house went down, so we were disconnected, unfortunately, significantly before I realized it, that I was talking to myself for probably half an hour. So we'll pick up, and there was a question from Stephen, I think, about if we were on an incident of a fire. And let me turn the radio down, excuse me. So there was a question about if there's an incident where there's actually a fire, and do we worry about scratching doors and things of that sort? Well, that's a good question, and the answer is one of those common sense answers that if there's actually a fire at a building, and we're not worried about scratching doors and things of that sort. You'll hear it saying a lot as you go through academy: risk a little to save a little, risk a lot to save a lot. And what that means is if there's rescues imminent, we will very seriously consider making entry, performing a rescue, and direct fire attack. If there's confirmation that there's nobody, no pets inside a building, and the building's pretty highly involved, we're going to risk little to save little. In the event of this question, it's a similar thing, where we damage little to save little, and we can create a lot of damage to save a lot if necessary. Case in point, we had a call over across from Station 5 a year or so ago. Is everybody hearing me okay?
Yes, sir.
Yeah.
Great, thanks. We had a call. Residents had not been occupied for quite a while. The reporting party said that the homeowner was out of state, and there's been an alarm going off inside the building for a good number of hours. And they weren't drastically concerned, but they were a little concerned that something might be wrong inside. We went, investigated. It sounded like a typical smoke alarm. with the bad battery. We were able to figure out a way to enter the house. It was very gently, forcibly entered. And we found, as we suspected, it was a bad battery or a bad detector. So we removed the battery, we made contact with the homeowner, told them everything was fine. We made entry, nothing was damaged, and we let ourselves out, and nobody could tell that we had actually made entry. So that's one of those situations where you have to consider, you know, what is the goal, and then take appropriate actions to affect the strategy and the tactics for accomplishing that goal. Good question. Does that answer your question?
We'll take that as a yes.
Okay. So this slide that's up, general considerations when using cutting tools. Was I cut off before this or after this?
I think
Before this, I believe.
Before this.
Appropriate PPE.
Yeah, right at appropriate PPE.
Yeah, John, you were talking about wearing hearing protection for training purposes.
Okay, so we were here.
Yes.
Okay. Okay, here we go. So as we get on scene, we have to understand, you know, what tools we're going to need, and then we have to understand how to use the tools. Obviously, inappropriate tool use can damage the tool, can harm the person that's operating the tool, can harm crewmates, and can harm victims that we're trying to rescue. Forcible entry, sometimes there's a chance that there is a victim down just inside the door. Many times, you know, we've seen that, you know, statistically, if there are victims inside a building, they will generally have been trying to make their way out, and they may be by a window or by a door, have been overcome by smoke or injured in some fashion, and they couldn't make it through the window or the door. So as we make entry, we want to make sure that the tools that we take in with us aren't being indiscriminately swung around as we're sounding the floor and sweeping for victims. We want to be very careful, or at least keep that in mind when we're first making entry. If we're taking cutting tools in, if the cutting tool is manual, obviously we have to know how to use it. If we're taking a powered cutting tool, we have to make sure we have appropriate power sources. You know, is it electricity? Is it hydraulic? Is it pneumatic? And then all the components that go along with that. Knowing what tools and how the tools operate is going to be extremely important. When you're asked to go to the truck to get something, you have to get whatever the something is, plus everything that is necessary to operate that tool. You have to know what tools cut and how quickly. Some tools are slower, but they might be smaller and lighter and quicker to move around. But if we're looking at going through a brick wall or a cinder block wall or even a poured concrete wall, you know, a small hammer isn't going to do the job. We're going to have to know and understand what we need to accomplish the job. And then obviously no tool cuts everything. So the most common firefighting tools we have are axes. We have on the left-hand side there is a pick head axe. Looks like it's in nice shape, fiberglass handle, nice and shiny and clean. Right-hand side, a flathead axe. It's being used in combination with a Halligan, making forcible entry on this plywood that's covering this door. Other tools, we have bolt cutters. Most of the larger apparatus and some of the utilities have bolt cutters. Very convenient for cutting bolts, cutting padlocks, cutting chains. We don't have any cutting torches. But if there was a big incident where there was a big building collapse or something of that sort, cutting torches can come in useful. There may be some construction companies that we could call. Gilpin Road and Bridge is sometimes called to assist with things, and they may have, you know, a portable cutting torch that could be used if absolutely necessary. Rebar cutters, that looks like it's a small hydraulic rebar cutter. We don't have any of those that I'm aware of. And then we have a whole list of different types of hand saws, depending on the rig and what people have put on specific, you know, engines. Power saws always have to be used safely, of course. Eye pro, hearing protection, hand protection. Using them incorrectly can cause significant damage. Never use a power tool that creates sparks or any tool that creates sparks in a flammable atmosphere. When we have a incident, we have a call for a smell investigation. 4 minutes ago, we just got a call up near Station 1 for an odor investigation. They're saying they don't smell anything, but if they do go in and they smell natural gas or propane, you don't want to be using tools or equipment that causes sparks, obviously. So being very situationally aware of the environment that we're going into, as well as what you are carrying with you, is extremely important. We've talked about PPE. Second point here, never force a power saw beyond its design limits. Understanding the manufacturer's recommendation is extremely important. When we start cutting with a saw, we want it to be at maximum revolutions or maximum RPMs to keep it from bogging down. And then again, don't use a power saw in a flammable atmosphere. Some tools that you wouldn't think are firefighting tools are very useful. We've used circular saws before, like this person is doing, for salvage, overhaul, and buttoning up a building after we had to make entry. Extinguish the fire. Homeowner, the building owner, wasn't going to be able to come to the scene that night, so we had materials at one of the stations. We took some plywood, cut it appropriately sized, and closed up the building for the homeowner. Rotary saws have interchangeable blades. Know what blade is on the rotary saw on the apparatus that you are on for the day. When you're doing your truck check in the morning, if you don't know what the rotary saw blade is, ask and find somebody who does. There's blades that are specific for wood, metal, or masonry, different tooth sizes. Some have carbide tip teeth. Some are multi-purpose blades, and some are very specific. Most of the blades that we have on the K12s or the rotary saws on our apparatus are multi-use, but there may be some materials that they're not appropriate for. So if in question, ask. Sparks from cutting operations have created additional fires, especially in another few weeks when things start drying out. Always good practice to have a charged hose line or a portable extinguisher with you or nearby during any cutting that's creating sparks. This is an obvious no-brainer, but there may be some instances where a worker has been trapped or may have gone unconscious inside some compartment in a commercial building, perhaps. We have to be aware what is stored in that compartment. Why did the person go down? Are they overcome with carbon monoxide, or is it maybe fumes from something that's flammable? All blade guards on rotary saws are not made of the same materials. Some are cast, some are sheet metal, some are some type of plastic. Carbide tipped blades can sometimes shatter and go through plastic blade guards. So understanding and paying attention to the appropriate blade on particular saws is extremely important. Reciprocating saws, most of our rigs have an AC powered sawzall of some brand or another. Sawzall is a brand, reciprocating saw is the generic term. It's surprising what you can do with a reciprocating saw. If you have a chance to do an extrication class, you'll definitely use one of these. And in the appropriate circumstances, you can take a roof off a car in less than 5 minutes with a sawzall. Consider that our other extrication tool, the main extrication tool, is a hydraulic powered cutters, rams, and spreaders. And it'll take us 5 minutes to get those off the truck and set up. In that amount of time, you could have pulled out the reciprocating saw, got it hooked up to a generator real quick, or if the apparatus has an AC power, plug it in, if you're close enough with a power cord, and be working already. Chainsaws are on most of our large rigs. They have wood cutting chains on them. Obviously, this saw on the right-hand side is being used to cut through masonry. Carbide tip chains are available. Chainsaws can be used to make entry through wood buildings, for ventilation through roofs, ventilation through walls, rescue through walls, as well as typical use of chainsaws cutting trees. We use them quite a bit for cutting down trees during windstorms. If you don't know how to use a chainsaw, you can and will learn. Don't use any tools that you are unfamiliar with. If you are asked or ordered to grab a particular tool and you don't know how to use it, you have to state that. Don't go guessing. Don't push yourself out of your comfort zone, especially in a situation where it can cause great danger or injury to yourself or one of your crewmates or one of the people that we're trying to rescue. Prying tools can open doors, windows, move heavy objects, provide mechanical advantage. This graphic shows using a Halligan, making entry through a door frame. Right up here is the fulcrum it's pressing. So you have this whole moment arm to create additional leverage to be able to put great amounts of force on whatever we're trying to move or open. Manual prying tools, typically a single piece of high carbon steel. Most of the Halligans are between 30 and 36 inches. Most of ours are around the 30-inch size. Other prying tools have different shapes. There's a whole slew of different types of hooks, New York hooks and Cleveland hooks, and practically every large city has come up with their one that they think is best, with the best size and the best features on it. Hydraulic prying tools are also available, both manual and powered. Manual prying tools, typically small, light, easy to carry. A lot of times will take more time because you're having to pump manually a lever to create the hydraulic pressure. Powered hydraulic tools have obviously that. They're powered either by an electric pump or a hydraulic pump and can exert great amounts of force. They're usually going to be larger. Sometimes we require some setting up with the power units. For the hydraulic tools that we have on our apparatus, the engine and pump component is very heavy and very large. Takes a couple people to move it effectively. Hoses need to be laid out, hooked up. Tools are very heavy. So the appropriate tool for the job. Here's a small tool on the right-hand side, this door opener. It has two small fingers that go in between the jamb and the door, and then it pries that door away from the jamb. Creates great mechanical advantage and fairly easy to operate, and you can see it's easily handheld. Pushing and pulling tools. don't have a lot of use for hardcore forcible entry, but they are a forcible entry tool. If we need to make entry through a window and need to remove the window pane, obviously a pike pole is very easy. It's lightweight, easy to maneuver when you're not talking the 12-foot model that firefighter is handling. And it's a great tool for going inside with because it's lightweight. You can sound the floor with it, but you can also sweep for locating victims and finding your way through a building with zero visibility. Striking tools are obviously another basic hand tool. Sledgehammers, battering rams, we have some small sledges. Halligan can actually even be called a striking tool. Forcible entry tools many times are used in combination. So we have the Halligan and the axe. One term for this is called the irons. Another is called a married set. All of our engines and tenders have a set of irons. For any call that's a fire-related call, these should be coming off the truck every single time. So once we are able to meet in person, we'll be able to start handling these, understand the different components, different parts of each of these tools and how they're used. So let's answer this question and discuss it a little bit. What's the most important factor to consider before performing forcible entry?
Has it been ordered by command?
Good. Say that it has, then what?
Understanding what's going on behind the door.
Good. And sometimes you won't know that until you're actually getting the door open, but that's a good point. Anybody else?
What tools might be necessary?
Yeah. You know, what entry point is being used, and then what tools go along with forcing that entry point after you've tried before prying, of course, right? Anybody else?
The type of door.
Yeah, exactly. That goes towards, you know, understanding what is the entry point. Is it just a typical residential door? Might even be hollow core with a knob and then a simple deadbolt. Pretty easy. Maybe a lot of places up here have the security storm doors where they have the bars. Sometimes, surprisingly, they're very easy to open. Sometimes they may have some slide latches that create more issues. Yeah, but understanding or having some idea of what the door looks like or what the window looks like so that you can anticipate which tools you may need is important, because you want to come off the truck with tools that you need immediately. You don't want to be running back and forth from the truck to the building. A lot of times it's not that close and it's uphill both ways, in the snow, in the dark, slippery, and wastes a lot of time and energy. So having everything you need with you as you are getting off the truck is a good plan of action. Okay, most of this goes without saying. Full PPE, using tools that are undamaged, using the right tool for the right opening, which is that last question was a good question. Use the tool only for its intended purpose. A lot of people will have an idea to use tools other than what they are designed for. Some tools are not prying tools. A pike pole is not a prying tool. If you try to pry with a pike pole, you're going to damage the pike pole potentially. When the pike pole snaps, you may injure yourself, one of your crew members, or somebody else standing nearby. Weight balance on both feet, good ergonomics, and enough room to operate the tool. If you're not sure that everybody around you knows that you're going to be swinging a tool, call out swinging, give a couple 3 seconds before you actually start the swing so that people will become situationally aware, understand what's going on, and then take action to protect themselves out of the potential injury zone. Everybody here, when is the last time somebody has used, if they have a sledgehammer, an axe, a maul, any kind of big striking, swinging tools? Or if you haven't, let us know that too.
I've had some fun this winter bashing ice.
Cool.
Just an axe for me.
Broke.
Wood.
Yeah, yeah.
I use sledgehammers for demolition when I'm doing old fences and stuff to get rid of concrete.
Mm-hmm. Good. So a few of you guys have had an opportunity. Once we have a chance to get together, if you haven't had a chance to be swinging big tools, you will get a chance. And it's something that you need to get a feel for. You need to get understanding of how to position your body, and we'll go through all those details with you. But it's something it's a learned skill, and you have to have some time with the tool in hand in order to get proficient with it. So, you know, as we get into the hands-on aspects of the academy, you'll get as much time as you want on that. So if you need more practice on things, let us know. So, excuse me, sudden release of energy when something is opened. If you're forcing a door, the door is going to fly open potentially. So you want to control that. You want to make sure that if you know somebody is behind the door, you're controlling that door so it's not flying out and creating potential injury. Being aware of the environment, manufacturers' guidelines and departments, SOPs. Reading and learning about tools is sometimes is an assumed thing, but in a lot of circumstances, it's important to learn how the manufacturer intended their tools to be used. And usually in those instructions, there will be maintenance and limitation requirements as well. Keeping tools in a designated place. Each apparatus has a specific location for each and every one of the tools. So once you get working on one of our rigs, you're going to learn where all these tools are. And it's extremely important, obviously, to memorize where are the irons, where's the water can, where is the glass saw. Little details like that will keep you from having to go through every cabinet, and you'll be able to run to the truck, grab whatever's needed immediately, and get back to be able to use the tool straight away. And then when you put the tools back on the rigs, ensure they're in the secured brackets. Loose tools can damage the tools themselves, can damage other things in the compartments, and they can cause injuries because if they move out of position, contents may have shifted in flight. So you want to make sure that everything is put back in its correct place and secured properly. Repair or replace damaged tools immediately. If something gets broken, it needs to be repaired or replaced. Don't put it back on the truck broken. We sometimes have things like that happen, and it's really frustrating, as well as causes issues. if we need a tool that had been broken and the next crew doesn't know that it's broken, it can be literally a life and death situation. Prying tools used incorrectly can create hazards. We talked about that already. Use a larger tool if the job calls for it. And don't use a prying tool as a striking tool. The pike pole we talked about. Operating power tools. We've gone through all of these already. The bottom line there, maintain situational awareness, is something we're going to be stressing constantly. And it's something that you should keep top of mind every minute. When we're using any kind of tools, especially power tools, we want to keep unprotected and non-essential people away. Following manufacturer's guidelines, keeping the tools properly maintained. Be aware of hidden hazards. If we just decide to start cutting into a wall without thinking and looking at the details of that wall, we may cut through power cords, power wires. We may cut through water lines, which could damage the saw. We could cut through both water lines and power wires, electric wires, and then all of a sudden have an electrocution problem. And then remember, the blades continue to spin once the trigger is released, especially on the big rotary saws. The blades spin down for probably at least 10, maybe 15 seconds. And there's a gyroscopic effect on those. So you can't just drop the saw and expect it to stay in place. You have to maintain control of whatever the tool is until the blade or the chain has ceased moving and it's safe to put down unattended. All right. Only thing here that we haven't talked about was the composite blade on the bottom. I don't think we have any composite blades on any of the rotary saws currently, but if a composite blade is in a compartment where gasoline is stored, it can be compromised in strength and hardness. So it's something to keep in mind if we start experimenting with different blade types. Keep this in mind. If tools are very heavy, find a crew member to help you carry it. Carrying tools can cause injuries. Axes obviously have sharp points and blades. Prying tools have sharp points. Striking tools are sometimes heavy. If we have battering rams, specific safety practices for each and every of those tools is important. So we're going to go through this just quickly. Steps needed to maintain forcible entry tools, because we are responsible for maintaining our own tools. If there's something that we can't or aren't able to do because we don't have the knowledge or we don't have the equipment or the materials, we can find it or we can put a work order in, and our maintenance technician will help us or get it maintained for us. So if the tool doesn't work for us, if it hasn't been maintained properly, if it's been misused, delays, injury, and or death can occur, literally. A lot of our tools have wooden handles. Wooden handles have to be maintained. They have to be inspected for cracks and chipping. If they're drying out, they can be sanded and linseed oiled. Fiberglass handles should be kept clean. Cutting edges need to be sharpened. Plated surfaces should be cleaned and not allowed to come in contact with chemical materials that can damage the plating potentially. Unprotected metal surfaces can rust And power equipment obviously has spark plugs and oil to be maintained at a certain level and changed at certain intervals. The proper type of gasoline, is it mixed? Is it pre-mixed? Is it straight unleaded gasoline? Is it the proper type of gasoline? Who cares for these? We do. All right, finally getting to the good stuff. Forcing our way through various types of doors. With doors, we'll sometimes have locks, padlocks. There's regular swinging doors, inward swinging doors, outward swinging doors, overhead doors of different types, and fire doors. First thing always, try before we pry. If it's locked, we have to determine the quickest method of defeating the locking mechanism. According to that earlier question, which was a great question, damage is justified by the severity of the emergency. You're just getting in to check a smoke detector battery. Doesn't require bashing in their whole sliding glass door. Rapid entry lockbox may be available on commercial buildings. Pay attention to that. If whoever is officer in command of your company and your truck, they might not think about it. They might not be familiar with that particular building. If you think about it, ask. Sometimes officers have a lot of other things on their minds and they're focusing on something else, pointing out, hey, is there an Knox box in this building? Could save a lot of time and damage to the building, cost to the building owner, and effort in order to accomplish whatever the goal is. Sometimes breaking the door glass is the best option when forcing entry. Now here's a picture. We have two side lights. We have a door glass that looks like it might have wires in it. Has anybody ever tried breaking through or inadvertently broke through a window that has the wire mesh in it? Captain Williams?
Yeah, I have.
What kind of issues do you have with the wire mesh windows?
It just becomes difficult, I think, when you're trying to sledge through because it'll break the plexiglass, but then the wire's in there. So I found you typically have to come back through with a rotor saw and kind of clear it out. I've only had to do it at a manufacturing plant one time.
Yeah, so the wires are typically in there for added security. So the point here is to determine what is the easiest and least destructive method of getting in through that door. In this case, probably breaking the side light glass. You could reach in and unlock the door. If the door has a thumb knob on the inside, there it may be a double lock set. So then plan B would have to occur in order to get in through this door. So I mentioned inward swinging doors and outward swinging doors. You can see the direction of entry. Here's the outside of the building or from where we are coming from. If you can't see the hinge, it's an inward swinging door, obviously. If you can see the hinge on the outside, it's an outward swinging door. And each of these has pros and cons, like everything, as to determining how to make entry through those particular openings. There's also double doors. Some homes will have these, not necessarily the full metal doors. Many commercial occupancies will have these as a side or a rear door where they use to bring inventory in or equipment in and out. So if you take a look at the door on the left, you can see what type of door is this, inward or outward swinging?
To outward swinging.
Good, good. So the clues here are the hinges are on the outside. If you didn't see the hinges, you can see this handle right here, which would typically mean that's an outward swinging door. Now, which side of these doors would be typically used on a day-to-day basis?
The left side.
Good, why?
It has the knob to open it and the handle.
Yep, excellent. So this is part of our size up. When we come on scene and we're doing a 360 or incident command or an officer asks us to size it up and make entry through this door, we're getting a lot of hints as to how the door opens and what type of tools, what type of locking mechanisms they may be. And then we can put together a plan, a strategy, and then tactics for what type of tools and what type of actions are going to be necessary in order to get in through these doors. Part of the size up also, start small, start large and then go smaller. So take a look at that whole building, the wall that the door is mounted in. What is the door frame like? And then get down to what type of door is it? You know, these are metal doors. Outward swinging, left-hand side is the active door. There's a knob, lock-in knob, looks like some kind of deadbolt. Looks like something had been right here at one point in time. Can everybody see my cursor?
Yes.
Yes.
Okay, great. It looks like it's maybe a little bit loose up on top here. So it may not be the most robust door frame in the world. So these are all things that we can use as we're determining which entry point we're going to use, and then the tools to go along with that. Here's a picture on the right-hand side, bars, doors with drop bars. So a drop bar is essentially some design. They'll have brackets on the inside typically. This one has two brackets with a 2x4 slid through them. You can see there's 3 bolts on each bracket holding the bracket to the door. Sometimes there'll be 2 sets of brackets. Sometimes the brackets will be on the door frame itself. Oftentimes these bolts have heads that protrude all the way through the door, and you can get an understanding of just looking at the outside of the door. You know, you may see the bolts on the outside of the door. So here's part of Captain Williams' presentation that I plagiarized. As I said earlier, start big and work small. What's the building construction? In this case, it has a brick facade at the very least. What's the material of the jamb? This looks like a steel framed security door. Is it single hung, double hung, inward or outward swinging, primary locks, secondary locks? What else might you not be able to see? Somebody want to take a stab real quick and do a quick size up of this entryway?
So beyond what you've already mentioned, outward facing, metal security door, unknown if the main door is inward or outward facing, guessing inward. And can't really see what the locks are, but security doors, looks like a handle of some sort.
Mm-hmm. Good, good. All right, so when I look at this, obviously we have the brick wall covering, we have a steel frame on 3 sides, outward swinging, 3 hinges in each of the doors. The right-hand side is the opening door. Looks like it probably has a deadbolt and then a lock-in knob. There's a latch guard that you can barely see here. So a latch guard is a piece of metal that is welded to the door that helps prevent tampering with the latch plate of the lock. Looks like there's probably some kind of lock or deadbolt mechanism here, some kind of lock box here. And you're probably right, Johnny, that the inward set, the inner doors are probably inward swinging. So plan A, size it up. Typically, we're going to do this with our set of irons using conventional force. The saying you're going to hear a lot is shock, gap, set, force. So shock, you can use the adze end of the Halligan to shock the door. You're basically top, middle, and bottom. Hit the door with that and get a feel for what the door feels like. Does it feel soft? Does it feel solid? Is the top a little softer than the middle and bottom? Does it feel like there's slide bolts or slide latches, top, middle, bottom? Can you feel maybe a drop bar in there? This will give you a really quick method of getting an understanding for what's going on with the locking mechanisms. Gapping is just that. You want to make a gap so that you could get a tool in between the door and the door jamb. You set the tool to the proper depth so that when you force it, the tool doesn't slip out of place. If plan A doesn't work, plan A harder isn't usually the best option unless you have real good confidence that second set of plan A's is going to work. So then you want to have a plan B, some other type of tool, some other method. If it seems like that particular opening is extremely robust and solid and it's going to take a lot of time to get through it, find a different way into the building. If plan B doesn't work, we have other tools on the rig. We have the rotary saw, we have the chainsaw, we have the hydraulics. We might have other forcing tools that are larger that might not have been as convenient as our set of irons at the very start. And then once we do get through the door, we want to control the door. And what this means is we don't bash the door open and just leave it swinging open. We want to, if we know or have a hint that there's fire and smoke inside, we want to be low because we don't want the smoke and fire coming out right at us. We want to control the door with the end of our tool, look inside real quick. What are the smoke conditions? What are the fire conditions? Can we see any potential victims? What does the room layout look like? And then we close the door, call incident command, say we've made entry, what's our next assignment? Keeping the door open allows a flow path for air to get into the building, and it can create serious issues for fire control in other parts of the building. Even on the very far side of the building, a window or a door open on the opposite side will cause fire conditions to change significantly. So here's our plan A. Shock, gap, set, force. You can see here, this firefighter is using the adze of the Halligan. He's trying to separate the door from the jamb. At the very least, he wants to make some space over here on the right-hand side. He's got the adze in there a little bit. You may have had somebody using the flat head of the axe to help him get that adze in there a little deeper. Prise up, prise down, makes more space. As you're making space, you're creating more accessibility for that adze or the other end, the fork end of the Halligan, to get in there and allow it to get set and then do your force move. So you can work the Halligan into the gap. You might use the axe as a wedge to capture progress. You might have a wedge in your helmet, on your helmet band, or in a pocket, or there's other tools that you can use to keep the gap, capture the gap, and then create more space in order to make enough so that you get the tool completely in. This comment here, ensure you do not peel the skin of the door. These types of doors, these are metal doors, and they'll sometimes have a wood or a foam or a hollow interior. So they're made up of three pieces. There's a skin on the outside, a skin on the inside, and then the frame pieces that go around the periphery, giving it its stiffness. If you capture, if you get only the outside edge and the side of the door, you can create a situation called skinning, where you're starting to peel the door apart. Sometimes when you do this, it's hard to come back from that in that particular location. The door will become all deformed, and you might not be able to get the adze or the forks in through that area between the door and the door jamb, and you'll have to go higher or lower, which could be an issue because you want it to be right here. You can see the bolts of some kind of locking mechanism that you were working on defeating, and if you have to go higher, it's not going to be as efficient. So making sure you get the adze or the forks in deep enough is extremely important, and we'll talk about that when we're doing hands-on. Here you can see a cross-section of what setting means. Getting the fork of the Halligan in deep enough so that it's not cutting into the door jamb itself. And then when they force this, the tool doesn't slip out of the opening. You can see the forks of the Halligan. This edge is called the bevel. And this is the door jamb. This is the door. So he has the bevel to the jamb. Bevel to the jamb is advantageous when you have a real tight door opening and you want to get that fork in there and make some gap. If the bevel was to the door, there's a high likelihood of the point of the fork digging into the door jamb if you're not controlling the Halligan well. So real tight doors, sometimes you go door to the jamb, or I'm sorry, bevel to the jamb, make some space, flip it around, and then the advantage of the bevel to the door is you have more swing room of the Halligan to force the door open. Forcing, this is just brute strength, like it says. You want to create as much force as possible, pushing your body against the tool in rapid, aggressive tugs or pushes. This is no place to just do a long, slow, steady pull. That impact force is extremely effective in getting the doors to, or defeating the locking mechanisms on the doors. On the right-hand side here, you can see two firefighters using a hook and a Halligan. The hook is extending the length of the combination of tools, creates a lot more leverage. It's amazing how much more leverage just an extra 6 to 8 inches or a foot will give us. One thing we need to be cautious of, though, is that these hooks aren't made for heavy duty prying, so we need to be cognizant of how far we're pushing those tools, using the right tool for the right job and not overextending the use of the tool, as we talked about earlier. Excuse me. Getting through bolts. Plan A, you can many times defeat carriage bolts using a Halligan and a flathead axe. If we have a drop bar, and we talked earlier about drop bars will sometimes have a telltale pattern of carriage bolts through the entire thickness of the door. So if you see it set a pair or two pairs of bolts, that could indicate there's a bracket on the inside of the door that's holding a drop bar. So these holes were made with the pick of the Halligan. Take the pick of the Halligan, put it just above the carriage bolt, have the flathead axeman hit and drive, make a nice big hole above the carriage bolt, roll the Halligan around, make the hole large, do the same thing underneath the carriage bolt, Once that hole is large, you can put the pick or the pike of the Halligan right on the center of the carriage bolt. Have the axeman drive, and you can push that carriage bolt right through these steel doors. Do that a couple times, bracket falls right off, drop bar falls out, you're into the room. If you're not able to do that, you can also take a rotary saw. On this left-hand side of this is where they've used the rotary saw to cut off the head of the bolt. Get the saw blade just in the gap on the edge of the carriage bolt and just cut right through the carriage bolt head, or you can actually get in and slice through the door itself, going deep enough to cut through the bolt itself. If the bolt doesn't fall off with the bracket on the inside of the door, you could take the pike of the adze or the pike of the Halligan and just push the bolt out through. So it's amazing with simple tools what we can do to make entry through some pretty robust entryways. If our first set of tools doesn't work and our plan A and plan A a little bit harder didn't work, we need to go to plan B, create or understand what other tools we have at our disposal. Here we have some through the lock tools. There's K tools and A tools and Rex tools. These are designed to be pushed around a cylinder lock, and then you can pull the lock out of the door. Many commercial doors have those types of locks, and it makes it real quick and easy with minimal damage to get through certain types of locks. Plan C, power tools, K12, chainsaw if you have a wood door or a wood wall. Here you can see you can get the blade of the saw right up in the gap between the carriage bolt head and the washer, or between the carriage bolt head and the door itself. And probably 15 seconds, if you don't slip, you could be through that carriage head bolt or carriage bolt head. Eric, do we need to take a break? Or do we want to power through?
How much longer do you think you got, John?
Probably half hour.
Why don't we, unless anyone objects, why don't we power through?
Copy. Okay, if we're looking at a commercial building and they have the big glass doors with the aluminum frames, we can't get through the aluminum frame or the door itself. We may have to take the window itself. Now, a tempered window is really, really strong, but it creates a lot of mess when broken out. So it's one of the last things we want to do as a plan D type of thing is to break the glass itself. When tempered glass breaks, it creates little roundish pieces of glass that can get down between your gloves and the sleeves of your coat, could get down the collar of your jacket. If you don't protect the opening like these firefighters are with a tarp, that glass will fly 10, 15 feet both inside and outside the doorway. That glass is going to be like ice then every time you walk across it, especially if you have a really hard flooring, concrete or epoxied floor on the inside of a commercial building. It's kind of a last resort. If you can, shield the glass when you're breaking it to try and control where it goes. You might call somebody to bring a broom over so you can get it out of the way if you have the time, the manpower, and the broom handy. Otherwise, people will be going back and forth through there, dragging glass in and out, as well as potentially getting it into their gear and potentially slipping and falling. So for other types of doors, sliding doors and then security doors and gates. Sliding doors, we have the glass panel doors like a lot of people have for their patio doors. And then interior pocket doors. Sliding glass doors, they do just that. They slide. It's difficult to force a sliding glass door in the traditional way. If the frame of the door itself is flexed to any amount, it'll typically shatter the glass. One way of getting through a sliding glass door is lifting the movable glass panel up with the adze of the Halligan or another tool, swing the bottom of it out, and you take it right out of the track. Sometimes there's a security measure in place where it's not possible, but that's something to look for if you need to get through a sliding glass door. Interior pocket doors. These are doors that basically just slide into the door jamb itself. Locking mechanisms on these are fairly easy to defeat. They're typically not a security opening. But again, do a size up, get an understanding of where you think locking mechanisms are, and then what are the tools that you can use to defeat that locking mechanism. On the right-hand side, we have security doors and gates. This includes roll-up doors. Roll-up doors can be slat-type roll-up doors. They can be a cage-type roll-up door. We don't have many of these in our district. I think probably over at the Ameristar warehouse. Some of the receiving doors at the casinos may have these. There may be locking mechanisms on the inside. The roll-up barrel may be on the inside or the outside. You have to just do a size up to understand where the locking mechanism is. If you can't defeat the locking mechanism or don't have access to the locking mechanism, you may have to go through the door. So a rotary saw may be the method to get through a roll-up door. Open steel bars. There may be a steel bar security grates on windows. You may also have steel bar doors on residential doors. I have them on my house. I always thought that they were going to be badass to break into, but then when I went to Mile High Fire Conference, I had the opportunity to go to Irons and Ladders, and they showed some videos of getting through these steel security doors. They're usually really rigid, and if something is rigid and has a big enough gap to get a tool into, they're pretty easy to defeat. So I need to add some slide latches and things to beef those up. But taking a look at what you have, open steel bar doors will typically have a latch guard over the latch plate, and it creates a perfect location for the adze of the Halligan to pry the door open. And then multiple slats that form some type of solid panel for a security door or gate. A lot of times with these, we'll need a power tool. Excuse me. So this type of lock, you'll see a lot on commercial doors. Every time you go into a store, you'll probably see one of these types of locks if you pay attention. And we have tools to get through those. We'll take a look at the construction of these, and you'll see how easy it is actually to defeat this type of lock. But upper left-hand corner here is called the K tool. It's kind of a K shape. The tool is placed over the lock cylinder that's protruding from the door. It's pounded down onto it. This edge and this edge dig into the lock cylinder itself. And then a Halligan adze is slid in to this section of the tool, and it's used to pry the lock right out of the door. These cylinders have small, very fine threads machined into it. And that thread interacts with the small wall thickness of the aluminum door itself. And there's usually only 2 or 3 threads. 2 or 3 threads of that fine dimension through an aluminum door is real easy to pull out. So you're pulling this lock right out. And a lot of times you'll be able to twist it back in. We can make entry, do what needs to get done, twist the lock back in, lock it, and it doesn't even look like we've made entry. Up on the upper right here is an A tool, A shape, same type of functional design as the K tool. These edges will sometimes dig into the door itself a little bit more than the K tool and cause a little bit more damage, but a very effective way of getting into these types of locks. The J tool, we're going through the alphabet. J tool is designed to go in between doors that have panic bars attached. So a lot of commercial buildings will have a double door or even a single door that has panic bars, which are those bars that you push against that unlatch it. This is small enough diameter wire that you can slide it in between the doors, twist it, pull it back toward you. This pushes against the panic bar hardware and the door opens. And then down at the bottom here, Captain Johnson mentioned shove knives. A lot of doors are fairly easily manipulated with a knife of some type, or a credit card, or a Swiss Army knife. Understanding the design of the mechanism makes it real easy sometimes to use an appropriate tool to get in between the door and the door jamb. Jiggle, wiggle, pull, twist, and you can depress this latch in usually a really short amount of time, surprisingly short, to make entry to that opening. Forcing padlocks, duck-billed lock breaker. You can see the shape of that tool with the wedge built into it. Put it into the lock. Apply sufficient force with a sledgehammer or a flathead axe, and you could potentially bust that padlock open. Bam Bam tool, the one in the center. We don't have any of these in our apparatus, but if you work with a department down in town somewhere, they might have some of these. It's got a case hardened screw. You screw that into the lock opening, and this red part of the tool slides on the tool handle, and you get this twisted in, screwed into the lock as tight as you can. Pull this back, and it's basically turning it into a hammer pulling the lock mechanism out of the lock itself. Rotary saw or a torch. If you have a padlock here, you obviously don't want to have your hand right where the saw is or a torch cutting that. If it's a case hardened or a high security lock, you may have to use a rotary saw. So what they're doing here is they have locking pliers like vice grips attached to a chain. They attach that to the padlock, pull on the chain, so the crew member over here is out of the way of the rotary saw. The padlock is stabilized so that the firefighter handling the saw has a good target to cut through the shackle of that lock. I mentioned rotary saws can be used to force entry in an overhead door. There's various techniques and methods of getting through these types of doors with a rotary saw, depending on what we're trying to accomplish. There's A-shaped cuts. There's double cuts, where you can see the firefighter here, he cut along the top, and then he's cutting along the side, so that you can either swing this part out and back closed. You could call that a barn door cut. It's great because the door stays attached on one side, so you can let firefighters make entry, and you can control the ventilation of that opening then. Another option is, depending on the door design, you can make this top cut, make a cut down the center or 2/3 of the way through, and then you can pull these slats out. Usually every other or every third slat has a feature that goes into the frame of the door mechanism itself. So these slats are free to slide sideways. A lot of times, if you take enough of these slats out, the door itself will have a counterbalance spring that will open all the way by itself. So before you make entry on an overhead door, be positive that incident command had that intention because once this door is open, if you're cutting and pulling slats out and that door opens all the way, it's going to be a huge ventilation point that can't be reversed. If you do get through the door, and that was the plan, add some cribbing so that if the door does come back down, it doesn't block egress. So we don't want to be trapped inside here with the door coming down, perhaps inadvertently, and jamming closed, and we don't want it to come down on our hose lines, of course. Warning. Other ways of blocking the doors open, there are sometimes slots or holes that we can put a wedge in. You could use vice grips to attach to the door frame itself to keep it from sliding back down. Again, we don't want to cut off hose lines, and we don't want to have the door come down, potentially jam itself shut so that we or our crew members can't get back out. My understanding is that the Academy has been reading and studying through a FEMA building construction class. Is that true?
Yes, sir.
Has there been any discussion in that class about fire doors?
I didn't see anything about fire doors.
Yeah, I didn't see anything in there, John.
Okay. All right. Fire doors are just that. They're doors that are rated to a certain burn time, and they are designed into a building to protect an area of the building or to separate out sections of buildings. Schools will have fire doors. Many industrial buildings will have fire doors, especially in areas where there's welding or forges or some type of high fire potential process. And what this does then is these fire doors, when the fire alarm is activated, the doors will automatically close and give a higher fire protection timeline to areas of the building beyond from the fire area. So it's important to understand where these are as we go into a building. If they haven't tripped yet, they may be closing behind us as additional alarms are set off or fire progresses through a building. So fire doors, they won't lock. We should be able to open them ourselves to make egress. Sometimes they're on electric latches. So it's a latch on a door that goes to a stairwell maybe, and it's normally open, but when the fire alarm goes off or they're activated by some other method, like the electromagnetic door locks, this one is deactivated, the door closes with a spring closer, and it helps isolate an area of a building or a room or a hallway. The Gilpin School has these across certain sections of the hallways through different sections of the school. A lot of times they'll be used to protect stairways. So all the doors into the stairway will be generally held open, but then when there's a fire alarm or a confirmed fire, the fire doors will close. They're still able to be opened for making egress or entry into that area, but they'll be spring operated or door closer shut to eliminate the ventilation path. So things to look out for as we do building inspections, walkthroughs, and good questions to pay attention to, or good points to pay attention to as you're reading through the essentials book for questions on the tests. Forcible entry methods for windows. Something that we need to pay attention to is when we are looking at making entry through a window, we not only have the window, but we also have window coverings. Inside the window, there may be screens. Some screens are pretty tough. There may be Venetian blinds, there may be curtains, there may be some type of security screen. Size up and situational awareness is extremely important. So we talked about ventilation issues. Now, once you guys get through fire behavior, you'll have a lot better understanding fire behavior and building construction of flow paths through buildings. Opening the wrong window could draw the fire to uninvolved sections. Fire likes to move toward areas where there's air present. If the building has been closed up tight and there's a fire, we go in through a window or open a door and don't control it, fire is going to move toward that open window. Obviously, it intensifies fire growth and it disrupts ventilation. What this means is intentionally or unintentionally opening a window will disrupt whatever ventilation pattern had been present before it was opened. So if we inadvertently or incorrectly open a window or break a window, or a window breaks because of heat, or a police officer with their big flashlight decides that it's best to let whatever smoke's inside out and goes around the side of a building and busts through 3 or 4 different windows, incident command is going to have an issue because they should have a plan for ventilation. Whether there's no ventilation or tactical ventilation, even one small size window can completely destroy that plan. Remember, glass shards are dangerous and they fly everywhere. Wire glass is difficult to break, and architectural glass, which has several layers, large panes, are extremely expensive. So if the building isn't completely involved or likely to be completely involved, not going through the expensive looking glass, if at all possible, is preferred. So in this case, there's a lot of glass. The glass block is somewhat difficult to get through. It may be mortar. It may be some type of thermoplastic adhesive. It could be plastic slats that are connecting these, but typically a glass block window is difficult to get through, more difficult than just regular glass. This door doesn't have much glass in it. Could be a difficult door to get through. In this case, if we didn't have to go through this side of the building, we may leave this as an option B or C. Go find a window or a door that might be more easily defeated. Double hung windows. This is one of the most common types of windows. It's called double hung because both the top and the bottom can be moved up and down. Usually there's a locking mechanism on the center slat. Sometimes there's one, sometimes there's 2, but they're usually located on the upper part of this section of the frame. And when the lock is activated, it keeps both of those sashes from being operated. So to get through a double or a single hung window, a single hung window is a window style in which just the bottom section slides up and down. The top section is fixed. Forcible entry through single and double hung windows is exactly the same. So step 1, size it up, try before you pry, take a look. Where are the locks? Is it even locked? So many times people don't lock them. In that case, it's easy. Insert the blade of the axe or the halligan under the center of the bottom of the sash, in line with the lock mechanism if at all possible, and then pry it. Hopefully you'll defeat the lock. Glass, window frame won't break, and you're able to open up that window. Put the lower sash open, and you can make entry or vent or check for victims or room and smoke conditions, whatever the particular reason for making entry through this window was. Other types of windows, I mentioned single hung already. Casement window is a type of window which has a crank. Usually the crank is on the hinge side at the bottom corner of the window. They're more difficult to force because you have to activate the crank in order to get the window to open. So you have to get inside the window somehow in order to get to the crank, in order to crank the window, in order to open up that window. Horizontal sliding is just that. It's basically a single or a double hung window turned 90 degrees. It'll usually have a latch in the center or two latches, just like the single or double hung. Opening method on this is the same as the single or double hung. Try it. If it doesn't work, understand which side slides and force that particular side. Awning type window, same thing. Understand where the latches are, how the window mechanism works, and then determine what tools can be used to move the moving part of the window. Duluthi, I think that's the correct pronunciation, is an old-fashioned style of window that you'll sometimes see a lot of times in like a storm door. So it's a window that has a lot of a whole series of slats of glass, and all of those, when the window is cranked, all of those will twist in the same direction. Projecting windows and pivoting windows, typically seen in industrial buildings, factories, some warehouses. They pivot and have different operating mechanisms, but generally are the same. A lot of times forcing entry into these just entails getting through the glass itself. If it's an industrial application, it may have wired glass. So understand that and find a different opening if possible. Hurricane shutters. I don't know if anybody up here, there are some buildings that have some types of shutters, whether they're removable or they roll up or they rotate out. Generally seen or more frequently seen on homes that are summer type homes. People close up their house in the wintertime and come up during the summer. If there's a reason to make entry in the wintertime or when these are closed up, you have to do a good size up, understand where the weak points are, where the locking mechanisms are, where the hinges are if there's hinges, and you put a plan in place to defeat those details. High security or Lexan. Lexan is a registered trademark of General Electric for polycarbonate. Excuse me. There's different types of polycarbonate. This material is extremely tough. Some types of bulletproof glass are made out of polycarbonate and layered polycarbonate. You can't break it, so you have to take alternate methods in order to defeat it. A sledge or an axe or a halligan is going to bounce right off this and probably hit you back in the front of the head. So you can see this firefighter is using a rotary saw, making cuts around the Lexan, trying to make entry into this particular opening. Important thing to remember here is having the appropriate blade on the saw for cutting whatever material you're going to cut. Lexan will tend to melt when it's cut, so having a blade that doesn't gum up is extremely important because you could put that saw out of order, out of service, if you gum up the blade with too much melted polycarbonate. HUD windows, or it may have been done by an out-of-town owner or a meth lab leasee or a grow house leasee, where they want to beef up the security of the windows. They don't care about light or ventilation. You can see it's typically pieces of plywood with 2x4s or some type of stiffening and security arrangement on the inside. They have carriage bolts going all the way through. On the outside, they have a reinforcing section of 2x4. And you can see in the side view how they're using the 2x4s and the plywood to secure the opening. In this case, with the tools we have, excuse me, defeating the carriage bolt heads or just going through the wood itself is more difficult than using just our irons, but it does give us a good opportunity to get through a particular opening with tools that we regularly carry, understanding that once this is open, it's open. If you cut through, you're not going to be able to close this back up. So sometimes maybe defeating the carriage bolts, you can reuse this piece of plywood if we want to control the ventilation after we've made entry for whatever the initial purpose was. Other types of designs, vacant protection systems, that was similar to the HUD, the barred or screened windows and openings. Sometimes they're put together real well, sometimes not so great. So if you absolutely need to go through a barred or a screened window opening, if it's barred, you can do what we talked about for doors. You can use the Halligan, strike it, see where the soft spots may seem, and learn where the locking mechanisms or the bolt mechanisms are, and then attack those directly. Get an understanding of what we're up against before just starting to beat things in. So miscellaneous types of windows and covers, what kind of dangers might we encounter?
You might not know what's behind them because they're kind of makeshift.
Good. Some of the locking or movement mechanisms may be sharp. If we make entry through some of those pivoting type windows, there may be a frame piece that's sticking out somewhere. So if we go to do a VEIS, ventilate, enter, isolate, and search. So if we make our way in, climb in through a window, and controlled fall down to the floor, we don't want to impale ourselves on some type of frame mechanism or some component of the window that we weren't aware of that was there. Making sure we remove all of the glass in the opening is extremely important. When we use the pike pole or another tool to break the glass, we want to break the glass from the top down. We want to make sure we're on the upwind side of the window. We want to make sure we, if at all possible, and at the very least our tool handle is above where we're striking the window. If the tool is lower than the window, or if we're lower than the window, the glass that comes flying out is showering over us. It can slide down the handle of our tool, go down in the cuffs of our gloves. Might not be found right away, but another hour into the incident, it can start making its way down into your sleeve and cutting your arms, or then when you take your gloves off and you're deconning and we're heading back in the truck, we may be dragging glass shards into the truck and having injury potential for both ourselves and our crewmates. All right, so breaching walls, sizing up the situation, what's the building made out of, your FEMA building construction will give a lot of details on this, as well as the essentials book. Is the wall safe to go through? Is it a load-bearing wall? If so, we need to take different measures. We can still go through it potentially, but we need to understand that it is load-bearing or not before we start going through it. Types of exterior walls: wood frame, brick or concrete, block, concrete and metal, and generally easiest on the left to more difficult on the right. Types of interior walls: plaster or gypsum partitions, drywall. We may have wood tongue and groove. We may have lath and plaster. And then in some commercial situations, we might have reinforced gypsum. Reinforced gypsum is basically a drywall wall that has a layer of Lexan or some kind of tough plastic on it to prevent easier entry. It's a security feature that a lot of stores might be using. So for getting through floors, what is the purpose? Why would we want to get through floors? We've talked similar to going through a wall or a window. Ventilation purposes. A lot of times below the floor in the basement, there's not a lot of ventilation opportunity, and we want to reduce smoke, reduce heat, provide a more tenable atmosphere for potential victims and firefighters